2010 AB free response 6. It is an AB only question. It was not on the BC exam. So we are given a diffy cube, right? That's a differential equation. dy dx equals x times y cubed. It is worth noting that this is separable, right? I could divide the y cubed over and move the dx over and get a separable differential equation. That's worth noting because that's the last thing they're going to ask you to do. If it's separable, they're going to make you solve it. All right, so they also did me the solid of giving me d squared y dx squared, meaning the second derivative of whatever this function would be. So you could have found that. It's a simple product rule, but they were doing you the solid of not making you find it. It does mean they're going to make you use the second derivative in one of these parts. Otherwise, they wouldn't give it to you. So let's start with part A. Write an equation for the line tangent to the graph y equals f of x at x equals 1. All right, so this question comes up all the time in all of math. Anytime you are asked for an equation of a line, right, you always, forever and always, for the rest of eternity, need two things. One, you need a point. They gave you the point. They told you it's when x is 1, and they conveniently gave you that f of 1 is a 2. So, yay point. Two, you need a slope, right? So, in calculus, if you hear a tangent line, right, tangent means that you find the derivative at that point, right? Sometimes it's not the tangent line, sometimes they want a slope of something else, the slope between 2 points, but you need a point, you need a slope, and then you take them together, and you give me your answer in point slope. There is no reason on the planet to simplify it once you give an answer in point slope. So, I already know the point, 1, 2. Check. I can find the slope because the slope is just the derivative, right? I want tangent slope's derivative. So in order to find my m sub t, which is what I'm going to call my tangent slope, I need dy dx evaluated at the point they gave me, which is 1, 2, right? So that's going to be a 1 times a 2 quantity cubed. That's an 8. So now I have my slope, which is 8. I have my point, which is 1, 2. So my job is to write my answer in point slope. So my answer is going to be y minus the y value equals m quantity x minus the x value. Done. There's no reason on the planet to simplify it. Now, the AP bothered to add the 2 over, and that's fine. They didn't even bother to distribute the 8. This is a great answer, and it's totally fine. Okay. Oh, I'm sorry. I lied. It's not totally fine. Let me give you one more. Haha, tricky. They said y equals f of x. Tricky. That means you have to solve for y, right? This is code for solve for y, right? That's what that's code for. So they did the lazy thing, the same thing I would suggest doing, which is just add the 2 over. So they did 2 plus this 8 times the quantity x minus 1. So again, the only reason you should ever simplify a point slope answer is if you are directly prompted to do so. Otherwise, do not, right? If they just say write an equation, don't do more than that. But because they directly said, y equals f of x, that means you have to solve for y. So again, I need to pick this answer, not this answer, but this answer is right if they just ask for an equation. So watch out for little tricks like that. Okay, so part B, right? Part B says, use the tangent line equation from part A to approximate f of 1.1. And then they ask you other stuff, but let's start there. So it asked me 2 things, right? Number 1, it says approximate f of 1.1 with your part A, right? So what that's saying is take this equation and plug in 1.1. So essentially, if I plug in 1.1, I'd get y equals 2 plus 8 times the 1.1 minus 1 would just be a 0.1, so I get a 2.8. So what they want me to recognize is that f of 1.8 is approximately a 2.8. That's the approximation they want. They want me to use my tangent line to approximate. So I'm going to erase A and give us some space to talk about the second part of the B prompt. So when I erase A, so the second part of the B prompt is why they gave you that second derivative at the top. So the second derivative at the top, let's see what they said here. Given that f of x is greater than 0 on the window from 1 to 1.1, is the approximation of f of 1.1 greater than or less than the actual f of 1.1? Explain your reasoning. Okay, when they ask you if a tangent line is over or under, right? If they ask you if it's an over or under approximation, they're asking you about concavity. It's a concavity question every single time, and let me show you why. If a curve is concave up, and you have a tangent line under it, right? There's my tangent line. If this is the actual value, and this is the approximate value, you can see that if the curve is concave up, The actual value is over the approximated value, meaning it is an under approximation, right? It's an under approximation. If a curve is concave down and you draw a tangent line, the actual is the curve, the tangent line is the approximation. You can see that physically the approximation is higher than the actual. So you've got an over approximation. So the reason that this is relevant is that when they ask you if a tangent approximation is under or over, it's really just a trick question about concavity. This curve is either going to be concave up or concave down, depending on the first or on the second derivative right here, right? Curve's either going to be concave up or concave down, and that's going to answer your question. So let's go ahead and walk through this. I know d squared y dx squared, right, is y cubed times the quantity 1 plus 3x squared y squared. Okay, here's what I know. They told me that on this exact window, right, on this window, so on the window from 1 to 1.1, they said that f of x, which is the same as y, is greater than 0. That means that this guy is positive on that window. He's not always positive, but because of that information, if y is a positive number, then when you cube y, it also comes out positive. This guy, on the other hand, is literally always a positive, because this is a 1, which is a positive number, and this thing is either 0 or positive, right? Like, because you can't get a negative out of an x squared. You can't get a negative out of a y squared. The smallest number you can get here is a 0 squared, right? If you square a negative, you'll get a positive. So this is 1 plus a value that is either positive or 0, meaning this whole thing also nets positive. So on this window, d squared y dx squared must be positive, which means I'm looking at this situation, right? So f of 1.1, they asked, is this bigger or smaller? You got to make sure the wording is right. F of 1.1 is less than, or so is greater than, right? So f of 1.1, the actual, right, is greater than the 2.8 because the tangent line is above the curve, right? The tangent line is above the curve. Oh, sorry, below the curve. My brain. Sorry, ignore my brain. It literally looking at the picture and wrote above. Tangent line is below the curve. Sorry, guys. All right. So, again, for me personally, I know this is stupid, but I mean, you just saw me do it, right? It's really easy to accidentally say the wrong thing, so I draw this picture every time. I also don't have memorized which one is an under or over approximation. When I think about this, I just draw a curve and say, hey, if I draw a curve and I draw the tangent line, what happens, right? It's easier to actually physically look at this. All right, so let's talk about part C. So at the very beginning of this problem, I said, hey, if it's separable, they're going to make you separate, right? It's going to happen. So sure enough, part C asks you to solve, right? So dy dx equals xy cubed, right? So the trick with these is if you don't separate the variables, you forfeit all the points. And this is generally 5 or 6 points on a free response, so that's a lot of points to forfeit. So I need to take the y cubed and move it over. I need to take the dx and move that over. So I'm going to get dy over y cubed equals x dx. This is not a natural log when you integrate it because it's not a y to the first, it's a y to the third, right? So you need to make sure that you recognize it is not a natural log when you integrate. So when I integrate both sides, I find the antiderivative. I'm going to get a y to the negative second over negative 2 equals an x squared over 2 plus c. We put the constant of integration only on the x side because although this guy technically also gets a constant of integration, it's a different c, and when I combine both c's to get them onto one side, I might as well just call them new c. Now, at this point, I don't usually solve for c. You could plug in 1, 2 and find c right now. I usually manipulate my equation a little bit first. So what I'm going to do is I'm going to multiply this entire thing by a negative 2 to start solving for y. Oh, it is worth noting that in C, they did that thing where they said y equals f of x. We've seen that before. This is code for solve for y, right? Solve for y, right? So be careful that they're saying solve for y. So multiply everybody by negative 2, and I'm going to get y to the negative second equals a negative x squared, and then I'm going to call it plus c sub 1. Because what I recognize is that doing negative 2 times some arbitrary constant just gives me a new arbitrary constant. It is important to note that my c and my c sub 1 are not the same c. By doing this, by absorbing that negative 2 times the c into a new constant, I've changed it to a different number. So I then recognize that this is 1 over y squared equals negative x squared plus c sub 1, and that the easiest way to solve this would be to multiply the y squared over and divide this whole thing back. So I get 1 over negative x squared plus c sub 1 equals my y squared. And I look at my original, so I can now find c. I can plug it in almost any time to find c. It's up to you. If you want to find your c now, you can. So one thing to note here is that I'm going to have to take a square root at some point. When I take this square root, what I want you to notice is that because this is a positive output, when I square root to solve for y, technically I write a plus or minus, but I keep whichever version of that fits with the initial value point I was given. Since this output is positive, it's going to have to be the positive square root. So when I take a square root, I'm going to get y equals the square root, just a positive square root, of 1 over this negative x squared plus c sub 1. That's what I'm looking at as my general solution, right? I then have to find c, right? So that's my general solution. I then have to find my c by using this 1 comma 2. So 2 equals the square root of 1 over negative 1 plus c sub 1, right? I square both sides. 4 equals 1 over negative 1 plus c sub 1. I multiply the negative 1 plus c sub 1. I get negative 4 plus 4c sub 1 equals 1. 4c sub 1 equals 5. C sub 1 is a 5/4. So the answer I'm going to go with, and I'm just going to give myself some room over here, right? I'm going to write my final answer as y equals the square root of a 1 on top of negative x squared plus 5/4. Now the AP had a bunch of different versions in their answer sheet, but this is one of them, and if you chose to stop there, there's nothing they could do to stop you. So that's absolutely